Hello and welcome everybody to this Azure Synapse Espresso. Today we're going to talk about a cool thing. So we've been talking a lot about all the optimizations you can take, but what if you want to analyze your environment and find what optimizations you need to do? For that, I'm joined again by our good friend Jovan Popovic from the product team from Serverless SQL Pools, and he's written a very cool script. Now, if this is the first time you're visiting our channel, if you like the video, just give us a thumbs up, and if you want to see more of our content, just subscribe. And if you want to see anything different, or if you want to actually ask some questions, just put them in the comments and we'll get back to you. So, Jovan, can you tell me what you've written?
Hey, thanks. So I created a T-SQL scripts or T-SQL library that can enable you to more easily troubleshoot performance on your serverless pool, to analyze your tables and views in serverless pool, find some problems that you have, or identify some queries that are executing, or find duration of query or amount of data processed. So this is one small T-SQL library that you can just download, install on your SQL serverless database, and you can run like 3 or 4 views or functions that can get some information from serverless pool. This is good because you don't need to learn about specific DMVs, specific catalog views for extracting information from serverless. With this 4 simple views or functions, you can easily get all information that you need and troubleshoot and optimize your serverless SQL pool.
Okay, great. So it's based on the DMVs. It's based on everything of the information we have inside serverless SQL Pools, right?
Yes, so you can open this view, you can see the code inside, you can write your own views, or you can just use them and just run queries from on top of these views.
Awesome.
So let me show this in action. The first view that you should use in this QPI library is QPI recommendations view. So if you run select star from QPI recommendations, you will see a bunch of recommendations that this library will find in your database. So this view will go to your metadata in sys table, sys column, sys views, and investigate, is there something suspicious or potentially wrong in your schema? So here you have name of recommendation. Here you have name of recommendation, score, what is the object where we have found the problem, so schema name, object, and column name, and the reason why we are reporting this recommendation. So probably it will be good to do something like select star from recommendation ordered by score, because the higher score will give you more important recommendations. So what can we see here? We have this recommendation, optimize column type. So by examining schema, we see that GeoID column in object ECDC COVID in schema name DBO has max size 8,000 bytes. So if this is some GeoID, so some identifier, you probably should not use varchar 8,000 bytes. Probably you should use some smaller types. And using smaller types will improve your performance. So if you go down to this result, you can see that many optimized column type recommendation, where it is recommending me to change my max size of 8K to smaller size. So here I have many string columns that I defined with varchar 8,000. Second type of optimization is optimize key column type. Again, it will examine all columns that have some ID, key, code name in the column name, and check should we change something in this column. For example, if we are using this column GeoID in some join predicate, it is better not to use 8,000 bytes. It is better to use some smaller type. So for this GeoID, if you join GeoID with some other table, it's better to convert this varchar to some int column. So this recommendation is advising me to change column type for these columns from varchar to some integer column or a big int column. There is also a set of recommendation for using better column type. For example, here I have in my table ECDC, I have date reported, load date columns, and it found that this is like varchar 8000 type. But it assumes that I should use something else. So probably since this is date reported, probably I should use something like date time type for this day. So in this case, it is scanning columns, finding what is the type, and assuming that maybe this type is wrong. Also, we have a recommendation for optimizing string filter. So imagine that we have some string columns in tables. And if you have string columns, it will be better to have a binary 2 collation on the string column, because in that case, you will have predicate push down in Parquet when you are doing something like select where column name equals something. So in this case, it recommends me to use something like Latin 1 general 100 bin to UTF collation, because if I apply this collation on this string column, I will get better performance. So there are many recommendations that we can see here, like optimizing column types, optimizing string filters, or for example, using varchar type instead of nvarchar type. So this view will just go to my metadata, sys column, sys table, sys views, find something that might be wrong, and it will show some recommendation how to change my table schema to optimize my performance of my queries. So in most of the cases, you should run this QPI recommendation view to see is there something that you can fix in your schema and this way improve your performance. There's another view, select start from QPI queries, that is returning all queries that are currently running on my Serverless SQL pool. So in this case, I have 3 queries that are reading data from some JSON files, and I can see that these queries are running when they started to run, and I can see some runtime information about these queries. So this is very useful if you need to find is some queries running and to check do I have some performance issues with this query. There is another view called QPI query history. So the previous view, QPI queries, is returning currently executing queries, but is not returning queries that are finished. So if you want to see all queries that are run in past, you need to examine history and run this query. Select start from QPI query history.
Okay, cool. Jovan, can I ask a quick question? How long is history we're keeping there?
The history is kept for, well, probably a couple of days. So history is there while server is running, and all this information are placed in memory. So while service is running and while this history is some temporary cache, it will be there, but eventually it will be lost. But I will show you some example how to query persistent history with another view.
Very cool.
So with this query, we can see ID of the query, request ID. This is very important information if you have some problem with serverless pool, like performance issue. This is the request that you can send to support, and they will use this request ID to find all details about your queries. You can see elapsed time. You can see what is the query text. So query text can be either real query text, like select top 100 or select top 1, or it can be collecting file statistics, scanning delta transaction files. So it will return you what is this query doing. It will return what is elapsed time in seconds and what is data processed in megabytes and what time and end time. So using this query history, you can easily see what is your workload, what is running on your serverless endpoint in past, and you can see what queries are completed, what queries are failed, what is average duration, and how much data they process. So another thing that you can do is you can find some query text by ID, and you can find all queries that have. What you can do here is to filter query history by query text ID, and here you will see all queries that are executed in past and you have the same text. So every time when you execute a query, the query will have the same query text ID, but it will have different request ID. So here you can see that I selected this select start from green, and I can see through time what is the query time of this query, and I can see what is data processed. So if you have something like regression and change in performance, like here, I see that this query executed once 13 seconds, and this time it executes 67 seconds. So by looking at this query history and filtering all queries with same query text ID, I can easily find what are the regress queries and when some elapsed time changed. Now, if I want to compare two queries, I can use this function QPI compare queries, where I'm specifying two distributed statement IDs. So this query will return information about query 1 and query 2. And here I can see that one query has 31 seconds, another 33 seconds. I will see start and end time. I will see differences in query text and differences in request ID. So this function is enabling me to easily compare two rows from this request history for two different distributed statement IDs. Okay, and you asked me how long is this query history persisted. So this query history is not persisted for longer time. It can be here like 1 day or a couple of days, but there is a way to find a persisted query history. So if I go to my Azure portal, if I go to my Synapse workspace, I can scroll down to monitoring diagnostic settings. So here I can add new diagnostic settings, and I can specify that I want to emit built-in SQL pools request ended, and I can add something like name of this diagnostic settings. When I do this, Serverless SQL Pool will emit information about your queries to log analytics, storage account, event hub, or some partner solution. So if I choose this storage account, I can select my Azure Data Lake storage account where I want to export this information. So I already did this, and I set up this diagnostic logs. So when I create this, Serverless will continuously export information that are very similar to query history into Azure storage account. And I can use Serverless to query this information. So let's imagine that I created this diagnostics. What I need to do is to create a diagnostic session in Serverless by executing this QPI create diagnostics and specify the location where these logs are stored. You can see this in your Azure storage account that you specified in these diagnostic settings. So when I create my diagnostic setting, it will be stored in some Azure Blob storage account or Azure Data Lake account, and you will be able to see some automatically generated folder or container where these diagnostic settings are placed. So when you go to your storage account and see this log file, you can create this diagnostics by running this create diagnostic store procedure. And after that, you will be able to query your diagnostics using QPI diagnostic view. So when I execute this, select top 100 star from QPI diagnostics, it will run query. It will query data that is exported to your storage. And here you can see probably the same information that you see in your query history. So here you can see duration in second, amount of data processed, distributed statement ID, and you will see query text, start time, query hash, and all other information. So this query history that is stored on Azure Data Lake storage account is persisted. You can control what is the retention period, and you can query it anytime. Also, you can set up multiple serverless pools to emit this history to the same storage account. And using this view, you can query telemetry. You can query history from different workspaces. And that's it.
Okay, awesome, Jovan. So basically anything we've talked about in previous videos about all these optimizations we can take, and you want to analyze that now, that script is really what you need. If you want to find that script, just look in the description below and you'll just find it and start playing with it. And if you have any comments or if you've enhanced the script, please let us know and we'll use that to help even more people there. Now, if you liked our video, Please give us a thumbs up. If you like the channel, just subscribe or put anything in the comments you want to see. That concludes the video for today. Thank you very much, Jovan, and I'll see you next time. Bye.